Hello everyone, this question was asked in my WhatsApp group. If you have questions and would like to learn more, please join my WhatsApp group. The link is below in the description. Let's get started. A very good question. And the trick in this question is drawing the diagram properly. If not, then you will get confused. It's a yes or no question, and the question is the point Q on the circle and the center of circle is given to be C. R is given to be a point on the circle, so somewhere on the circle, and the distance between Q, which is the point, to R is equal to Q to C. R is given to be on the circle, and what is given is that the distance between Q, wherever this Q is, between R and Q and C and Q is the same. So if you think of RCQ as a triangle, then side QR is equal to QC. Now what that means is this is isosceles triangles with two equal sides, and if I draw a perpendicular bisector to RC, then Q can lie on this line anywhere. Alright, so Q could be here, and we could have QR equal to QC, or Q could be here, which means Q is on the circle, and Q could be here, Q could be here, anywhere. What that means is we cannot definitively say yes or no to the asked question, so this is insufficient. Let's go to statement number 2. This gets tricky because the comparison is a little different. S is given to be a point on the circle, so let's just put S somewhere, which is not same as SR. And it's given that Q to S is equivalent to S to C. So the distance between Q and S is equivalent to different distance between S and C. So now S is the focal point and the distance between C to S. So this is where Q could be. But let's look at what other values of Q could be, right? So Q could be here, Q could be here. In fact, Q would be on a circle with center S and C as one of the points of the circle. So Q could be anywhere here. And it would still satisfy the condition that SC would be equivalent to. Again, as you can see that for some points, Q is on the circle with center C, and for others, Q is outside and still satisfies the condition number 2. So condition number 2 is definitely insufficient. However, when we combine them, we are going to do something different. We are going to superimpose these two circles and get to a new circle. Superimpose these two circles and see what happens. So let's draw the circle with kind of the same, just superimpose these two. So we have this circle with center C. Q could be anywhere on this line right here and anywhere in this circle with S as the center and C as one of the points here. So when you combine these two, Q could be here at the intersection of the line and Q could be here as the thing. What answer does that give you? That gives you the answer that Q cannot lie on the circle with center C. And if you stop there, then you're done. You get the answer wrong because you mark it as C, saying that you have a convincing answer that Q does not lie on the circle. And why would you be wrong? The reason you would be wrong is because R and S are figments of your imagination, right? You have chosen R to be here and S to be here. However, there could be conditions where R and S are not these. R and S are, for example, same. When R and S are same, things could look different, and that's what we are going to see. So assume R and S were the same points, and this is where the trick of the questions comes in. So let's draw our circles again. As we draw our circles again with R and S as the same points, again now we have to figure out where the Q is. We know Q has to be on this circle and on the perpendicular bisector of C and R, which would be this line over here. So the possibility for Q would be these 2 points, both of which lie on the circle with center C. And in this case, and in only this case, Q will lie on the circle. Or we have 2 possibilities. If R and S are two different points, then Q lies outside of the circle always. And if R and S are same point, then Q would lie on the circle always. However, neither of these cases has given to be the case, so Q could lie outside or Q could lie inside. Hence, when you combine them, are not sufficient. The answer to this question is E.